2, it's really important that we factor. So, rewrite your first one. Notice the bottom is a difference of squares. It's x minus 7 and x plus 7. A plus sign in between. And the second one, it can also be factored. And sometimes in these questions, you can kind of get a hint from your first factors what might be possibility in your second factors. I mean, it's not a hard one to factor, but they like to repeat something later on. So it's kind of like, oh, I see why they have plus 7 again. Now, when we go to get a common denominator here, we notice this first one is missing one more x plus 7, so we multiply top and bottom by x plus 7, and we notice this one is missing an x minus 7, so we multiply top and bottom by x minus 7. That gives us a common denominator. And that common denominator, are you okay if I put the x plus 7s together and just call it squared to save a little bit of writing? So we have an x plus 7 squared and an x minus 7 plus, and then over here we'll have an x plus 7 squared and an x minus 7. And if I distribute in the top here and distribute in my numerator over here, first one I'm going to get 7x plus 49, and here I'm going to get 3x minus 21. And that, of course, will be grouped together there and grouped together there. So the rule for adding and subtracting fractions, so we need a common denominator. And that's what our plan was. We got a common denominator, and once you have the common denominator, your denominator stays the same. So I can write this as x plus 7 all squared times x minus 7. And then I can combine my numerators and add them. Do I have like terms? Yes. 7x plus 3x, 10x. 49 minus 21 plus 28. Again, this would get grouped together. And we can only simplify or cancel something out if we're multiplying and factors are identical. Do you notice the top? We could factor though. There's a common factor. What could you pull out of 10 and 28? You could pull out a 2. So I'm going to pull out that 2. 5x plus 14. Still have, because I'm checking, now do I have something the same? No. But we wouldn't know until we factored completely. Maybe there would be something the same that we could simplify. Again, the textbook says the non-permissible values. X can't equal negative 7 and x can't equal 7 are two non-permissible values. Now for part B here. N minus 3 leaves the space. And if I factor the bottom, no subtraction. And the other one I have n minus 2. And then I'm going to factor the bottom there. If you have time, try to factor it before I put the answer up. So the first one have the n and n plus 6 and minus 3. And for the second one, n and n plus 5 and minus 4. And this is a single factor. I could put brackets around there. Now, if you do math like a robot, which means you just follow steps and do steps you did in previous questions, things will go very bad very quickly. You need to do math with the rules that are there are important to follow, or the steps are important to follow, but we have to think along the way. This is a question where if you're not thinking along the way, it's going to end up disastrous. Your method won't be wrong, but you will run into a disaster. Okay? The reason here is, when can we simplify? When we're multiplying and when factors are identical. Look at this first fraction. Do you have identical factors, and are you multiplying in this first fraction? Yes. So it would be very, very, very important in this question to see that those will simplify. Normally I just stroke things out, but because it gets rid of everything on the top here, I'm going to add just a reminder that when you simplify something and cancel it out, technically you're leaving yourself with 1 over 1. So I'm going to put those 1s there. And I'm actually going to take the time to rewrite this. So now I would have 1 over n plus 6 minus n minus 2 over n plus 5, n minus 4. Okay, nothing else simplifies, but now when I look at this, if I want to subtract fractions, I need a common denominator. You see this first one is missing 2 things. You would need to do the n plus 5 and the n minus 4. And the second one's only missing 1 thing. N plus 6 over n plus 6. Why was it so important that we canceled out that n minus 3? Don't copy this down, I'll just do it in orange. But if you didn't cancel out the n minus 3, do you see that you would have had to add the n plus 6 and the n minus 3 here to get the common denominator? That's not wrong. If you worked with this, you could still get full marks. However, this is what's going to happen. What happens when you multiply 3 things like this? You'd have to multiply 2 of them first, and you would get an n squared. And then when you multiply by the third one, you would get an n cubed. Okay? Not the end of the world. But in order to write it in simplest form with the n cubed on the top, you would have to know how to factor equations with n cubes, which is a grade 12 topic you'll learn next year. None of you know it.
And at the end, you can factor out an n minus 3.
You would be able to factor out an n minus 3 out of the n cubed, but you'd have to know how to do that with synthetic division and write the following factored form of that polynomial, which I know you don't know how to do. And then it gets disastrous, because your final answer has math that's too hard for where we're at right now. This unit is very hard, is very easy if you miss something to make the math too hard that we can't do. If you know the too hard math and do that, you can still get full marks. But I don't think many of you have decided, oh, I want to do it the harder way, so I'm going to look up Mr. JR's videos and watch them all from the grade 12 year next year, so I'm ready to do it the harder way. I don't think we want to choose that. So this would cause a disaster. Instead, if we factor that out, it still doesn't look great. Our situation looks a little bit tricky, but I have a common denominator, and I know it's annoying to have to rewrite these, but it's very important that every step that we write is exactly the same as what was above. So you have this in the denominator. It still needs to be there. And we're going to have to combine like terms on the top. So I'm going to multiply this out, which gives me n squared plus n minus 20, which we already knew because it was in our original question. And I'm going to multiply this out, n squared plus 4n minus, 8 minus 12. Outside is 6n, inside minus 2n, that gives me plus 4n, and 2 times 6 will give me 12. And because we're subtracting, really important to remind yourself, I'm subtracting all of that. So that's why I had it in brackets, because it's connected as a single factor. And now, how do we add fractions? Well, we keep our denominator the same. So I'll have n plus 5, n minus 4, n plus 6. Combine my like terms on the top. I'm going to have n squared, and then these arrows are nice. Oh yeah, it's minus n squared. Those cancel out. I'm going to have n minus 4n. That'll give me negative 3n. And I'll have negative 20 minus a negative 12. Well, minus a negative, that'll be negative 20 plus 12, negative 8. I look at my numerator. It would get grouped together. Is there any common factor you could pull out of there? No. I mean, you could pull out a negative 1 if you wanted, but you can leave the negatives there. That's fine. But it will not cancel out with anything on the bottom. The textbooks writes the non-permissible values. I want to just point this out, because often students will write the 3 no problem and miss 1. Here are the 3 that are no problem. Those are all on the bottom. Which one do they miss? The n minus 3 was on the bottom earlier in the question. It's still a non-permissible value. So, questions for practice. 6, 7, 10, 12, and 13. Make sure you're checking your answers. You will make mistakes. When you make a mistake, see if you can find your mistake. Sometimes you won't be able to find your mistake. Please ask. Say, Mr. J.R., I can't see what I did wrong. Because it's in seeing where we go wrong that we get better at not making those mistakes in the future.